So in this lesson, we are going to learn how to write equations of lines that are parallel to a given line. So hopefully yesterday in the investigation, you realized that parallel lines have the same slope, the same rate of change. They're headed in the same direction so that they never intersect. So what we're going to do to set up our new equation is to first of all analyze the given equation. So one way to organize your work is kind of in two columns, given and new. New is what our goal is to figure out what the new equation is. So we first of all determine the slope of the given equation. It's in slope-intercept form. So what we're multiplying by the x is our slope. So there's our given slope. And then our given y-intercept is what we're adding or subtracting. Alright, then we start by determining the new slope. Knowing that parallel lines have the same slope, the new slope is the same as the given slope. Alright, so then we set up our point slope form. Our question, by the way, is what is our y-intercept? That's what we're looking for. So we substitute into our point slope equation, or our asylum equation. So our slope we get from the new, substitute that in. The point is in the question, so putting the -1 into the asylum, it becomes a +1. Our 4 goes outside the asylum, so it stays at +4. We did that part, so now we're going to solve for y, put it into slope-intercept form, and that will give us our new y-intercept. So we distribute our 3, and then simplify, combining our like terms. So we discovered that our y-intercept is 7, the new y-intercept. The last piece, we're going to graph both of these lines on the same set of axes. I'm going to start with my new line. Our y-intercept is 7, so we go up to 7 on the y-axis. And then our slope is 3. Remember, if your slope is an integer, you can turn it into a fraction by putting it over 1. So that's our rate of change, rise over run. So we rise 3, run 1. I like to use more of my graph. So from my y-intercept, I'm also going to fall 3 and run left 1 to keep that rate of change constant. And don't forget arrows on the ends of your line. All right, now we're going to graph the given equation. Our y-intercept was -2, same rate of change. So I'm going to extend my graph all the way up and all the way down. Oops, over too far. What's nice about graphing once you have those two equations is you can see that the lines are parallel instead of just figuring you must have done the work correctly. If your lines aren't parallel once you graph them, you can go back and find your mistake. Let's take a look at one more before we move on to our next topic. So we've got, again, we want to set it up with the given equation and the new. So we identify our given slope, which remember is what we're multiplying by the x. If all we see is a negative sign, we're multiplying by -1. Y-intercept is what we're adding or subtracting. So our goal is to find the new slope and the new y-intercept. Our new slope is the same as the given slope because parallel lines have the same slope. And we're going to figure out what our y-intercept is. So we set up our asylum equation and substitute in. Substitute our new slope, which happens to match the given slope, and the ordered pair that we were given in the question. So the 5 is going inside the asylum. The +0 goes outside the asylum, but that won't change anything. So you can write it, it'll simplify out later, but when I recognize that adding 0 doesn't change, I don't bother writing it in the first place. So we distribute our slope, and we have our new y-intercept. And finally, we are going to graph these. So I'm going to graph my new line first, going up 5 on the y-axis for my y-intercept. And my slope is -1, or -1/1. Make sure when your slope is negative that your line falls. So down 1, right 1. Or, oops, got that up 1, left 1. And then I will graph my given equation. My y-intercept was 1. Same rate of change, so we have that kind of corner to corner graph. And up 1, left 1 as well. And again, visual reminder that the lines are parallel and what it means for lines to be parallel.